Hello friends, welcome back to our channel. In this video, I'm going to share with you something very important. In fact, it is a step-by-step approach to convert any flip-flop to another flip-flop. For example, if you want to convert D flip-flop into T flip-flop, JK flip-flop into D flip-flop, or any type of that conversion, this technique will help you. This single technique will help you to convert any flip-flop to any another flip-flop. Friends, I developed this technique on request of many of our subscribers and members. And this is the most obvious question that is asked in the interview procedure. And at the time of interview, because of interview pressure, we could not think how to convert one flip-flop type into the another one. So I thought I should develop a technique. With the help of that step-by-step technique, you can convert any flip-flop to another flip-flop. Friends, now without wasting much time, let us get started and see this secret digital design technique. Friends, this technique has 4 steps which are very easy to execute. In the first step, you have to draw the given flip-flop. For example, if you want to convert a D flip-flop into T flip-flop, that means D is a given flip-flop. And given input is T because we want to convert a D flip-flop into a T flip-flop. So you have to draw both of them and unknown combinational logic to be found. So it will be clear actually as we proceed further. Second step is you have to write the excitation table. You will come to know soon. And the third step is we have to drive the expression or equation for the flip-flop input. And the fourth step is after knowing the equation or expression, we have to complete the logic diagram. Now let me reveal all these 4 steps by taking some examples. Friends, let us take an example that I want to convert a D flip-flop into a T flip-flop. So as mentioned in the first step, I have to draw the given flip-flop. And the given flip-flop is D flip-flop. And the given input is T input. And I have to draw the unknown combination logic to be found. So this is the unknown combination logic. So this T input and this Q both will go to this combination block and finally it will drive the D input. So this is very important to be found. And that is the crux of the video that we have to figure out this combination logic. And once we figure out the combination logic, our problem is solved. Now friends, the second step is we have to write the excitation table. As it is clear that input to this unknown block is T and Q, so let me write all the possible combinations for this T and Q inputs. 0, 0, 0, 1, 1, 0 and 1, 1. These are 4 possible combinations of T and Q. Now here I am writing Q plus. This Q is the current state of this flip-flop. Q plus is the next state. Friends, because we are going to build a T flip-flops, so this next state will be as per the truth table of T flip-flop only. So when T is 0, Q is 0, what should be the next state? Next state should be unchanged. So it will be 0 only. If T is 0, Q is 1, again output should remain as it is. So it will be 1 only. So when T is 1, Q is 0, that means output should toggle. So output was 0 and it will become 1. When T is 1, Q is 1, output will toggle and it will become 0. Now here excitation table means how the flip-flop should be excited. What input should be given to my flip-flop so that it should give me the desired results. So this is the expected output and this is the output of T flip-flop, but eventually it is the output of a D flip-flop. So what should I apply at this D input so that I should get the expected output? As we know that whatever is applied at the input of D flip-flop, it simply passes to its output. So Q plus is 0, so I should apply 0 here. When Q plus is 1, I should apply 1 here. Similarly, if I want to get output as 1, I should apply 1 at the input of this D flip-flop. If I want to get 0, so I should apply 0 at the input of this flip-flop. So D is exactly similar to Q plus. With this, our second step is done. Now let us move to our third step. Drive the flop input expression. So we have to drive the expression of this D input. Friends, here the expression is very easy. It is T XOR Q, but otherwise you need to draw the K map. Let me draw the K map also so that it should be clear to all of you. for other flip-flop conversions. So this is how you should draw the K map. Here I am taking T input, here Q input. So as per this table, so 0 should come here, 1 should come here, 1 should come here, and this 0 should come here. So here I am not going to discuss K map in detail. So this one will yield 0, 1. That means T bar Q. And this one will yield T Q bar. And this is an expression of XOR gate, T XOR Q. Now let us complete our final step, that is to complete the logic diagram. So from this expression, it is clear that I need to put an XOR gate. An input will be T and Q, and output will be applied to D flip-flop. So this is our final logic diagram. Input to this is T and output is Q. So finally it is a T flip-flop, which is made up of D flip-flop. Friends, now I have a question for you. And the question is, you have to convert a T flip-flop into a D flip-flop. And now you can pause my video here. Try to think of its answer. Try to apply this 4-step technique. And if you come to know its answer, please write it down in the comment section so that we can start a discussion there. And with this, I'm going to end this video, and I hope that this would be quite informative for all of you. If you also like this video, please press the like button and share your feedback in the comment section. And in future also, we are going to create many such videos. So to be aligned with our channel, don't forget to subscribe it and press a bell icon to get the notification of all the upcoming videos. Thank you so much for watching and your time.